So we're going to talk about the characteristics of quadratic functions. Let's start with the zeros of a function. The zeros of a function. That means if it's y equals some function of x squared of the quadratic, it's when does that equal 0? So on the graph, when does it cross the x-axis? When y is 0, it's crossing the x-axis. So, first example, let's just make some examples on here. There's 3 different possibilities. Let's draw them all. So the 3 examples are here. So the first one, quadratic that goes like that. Second one, quadratic just touches the axis, the x-axis. And the third one goes on past into there. So what we're looking at is no zeros. It did not cross. 1 0 did cross just once, just right here. And then here it crosses twice. This is 2 zeros. So what we're going to look at here is based on this number of times it crosses, we can find some more information. We're going to find the axes of symmetry. We're going to abbreviate that AOS. So when we do that, we're going to find that there are 2 possibilities. The first example we have, it hit once. So the axis of symmetry, of course, is where the parabola repeats itself right and left. So that would be the axis of symmetry here. Let's just say that that was -2. So the x equals -2 is a line, a vertical line, where everything on the right is symmetric to everything on the left. My drawing may not be perfect, but you get the idea. And that would be the axis of symmetry. Here, if it did cross, let's repeat the same graph. It crossed here and here. Let's say that is -1 here, and this is 5 here. Then halfway between the 2 is the axis of symmetry, because these are symmetric. This would be x equals what? How would we find that? X equals halfway between here 5, minus a -1 is 6, so 5 minus 3 is 2. Let's write that out. That's the axis of symmetry. Mathematically, we're talking about the difference between these 3, 5, minus a -1 divided by 2 is equal to 6 over 2 is equal to 3. So we can also find the axis of symmetry from a formula. So y is equal to ax squared plus bx plus c as a general quadratic formula, where a is the coefficient of x squared, b is the coefficient of x, c is the constant. So the coefficient a and b are critical for calculating the formula for the axis of symmetry, because it's x equals to -b over 2a. So let's write an example for this. Y is equal to -2x squared plus 4x minus 1. That would give the axis of symmetry as equal to a -b, and here's the b, over 2 times a is -2. So that would be -4 over -4 is equal to 1. Let's just put this in picture here. The axis of symmetry for this quadratic, and let's just graph the quadratic to make sure we understand what's going on here. So it's going to cross here, it's going to go up here, and come back down. And that would be at axis of symmetry, x equals 1, axis of symmetry. So how do we find this value here? How high up did it go? That's the next thing we'll do. The last of it is the vertex. That highest, or in case it's a happy parabola, the lowest point, vertex. And that we now have the x value. What is that y value for this point right here? We can find that by putting it into the equation. Y, when x equals 1, is equal to -2, 1 squared plus 4 times 1 minus 1. Oh, don't need parentheses there. -2 plus 4 minus 1, it would equal 1. So this value is 1. There's the pair. So let's try one for an example. Let's try this on your own here. Example. Find the axis of symmetry and vertex. And here it's at. We'll do this equation. And I'll draw a picture here of what we've got. So find the axis of symmetry and vertex for this. You'll need to know some critical points. Let's make this -3. Let's make this 2. Okay, pause the video. Okay, so halfway between those two would be the axis of symmetry. Graphically, it's about there. X equals what? So we would go to add the two together. 3, the difference between, so we have 2 and we have 3. So it would be 2 minus a minus 3 over 2 is equal to 5 over 2 is equal to 2.5. So we take that 2.5 and we say 2 minus 2.5 is 0.5 negative. So this distance here is 2.5. This distance here is 2.5. That's where we have the center between these 2 points. So x equals -½ Now, can we find the vertex? We cannot, because we don't know how steep this is. But let's do another example. And this time we'll give the equation. And at this point, you should be able to find the vertex also with the equation. So let's do another example. Find the same thing for y equals 2x squared minus 4x plus 5. Pause the video. I'll give you a chance to do that. Okay, so on here, so we know from the formula, x is equal to -b over 2a. We know the axis of symmetry is -4 over 2 times 2. So this one goes here, and this goes down here. So it's +4 over +4 is equal to 1. That's the x value of the axis of symmetry. And the y, when x equals 1, would equal 2 times 1 squared minus 4 times 1 plus 5. That's equal to 2 minus 4 is -2 plus 5 is 3. So graphically, we'll sketch it. So we know the axis of symmetry is at 1. X equals 1, axis of symmetry. And goes up to here. And is it a happy or a sad parabola? It's a happy parabola, goes up. Well, that's kind of wimpy line. Here we go. And that is ordered pair for the vertex. We'll label the vertex at 1, 3.